Okay, well, hi. Remember, this is the accident, the insurance company problem, and we were given this data. You should probably watch the previous video if you forgot it, or you can also look this problem up in the book. So, insurance company categorizes people as accident prone or not. It assumes the probability a randomly selected person is accident prone is 3/10. Probability they file a claim in the next year given they're accident prone is 4/10. Probability they file a claim in the next year given they're not accident prone is 2/10. And we just found the probability that a randomly selected person files a claim by conditioning on whether they were accident prone or not. And in this case, we developed this trick of decomposing the sample space so that we have written the probability of C as the union of the probability of C over this decomposition, either accident prone or not accident prone. If I had 12 different categories that the insurance company, I would just take a union of 12 different intersections of C with each category. As long as they're mutually exclusive and their union is the whole sample space, this is valid just from these steps, right? Basic axioms. Okay, and then you get to here and you can just compute this sum. Then you have intersections, and here's where you use the conditioning step. Okay, so let's say now part B was find the probability that they are accident prone given they file a claim. Well, this is just one more step really to the above problem, okay? So here we will just solve it by this. We'll say P accident prone given they filed a claim. I can just write it like this, right? PAC over PC using the definition. And now PC, we already saw up here, we wrote PC as the union here, or really as the sum of these two because they're mutually exclusive. So this is equal to PAC over PAC plus P a complement C, right? Because that's just PC. And in fact, each of these we can do by conditioning. We did them up here already, right? PAC or CA is the probability they're accident prone times the probability they file a claim given they're accident prone. Okay, so let me do it. Let me just do it again quickly since it is a new video. So this is equal to probability they file a claim given they're accident prone times the probability they're accident prone. Probability they file a claim given they're accident prone. Probability they're accident prone plus probability they file a claim given they're not accident prone times the probability they're not accident prone. We did this up there. I just want to do it again. So probability they file a claim given they're accident prone, 4/10. Probability they're accident prone, 3/10. This is the exact same term down here. Probability they file a claim given they're not accident prone is 2/10 and 7/10. And now the thing to do is just to, don't want to go to a new page for this, is just to multiply by 100, right, on the top and the bottom, and I get 12 over 26, right? 12 over 26 should be. Or reducing it more, 6/13. So one thing you notice is the probability they filed a claim given that they were, the probability they were accident prone given they filed a claim is less than half. So more likely that they're not accident prone if they filed a claim. And why is that? Well, the reason is this, right? This term, the 7/10. So this 7/10 makes the fraction smaller because there just are more people that are not accident prone according to their model. So even though they're less likely to file the claim, that comes into account, right? There's just the population factor that most of the people are not accident prone. Well, you can imagine this carries on into other types of problems and can get more involved when you factor in even more different circumstances. Okay, let's do one more of these types of problems. So suppose we have example. Suppose we have two boxes. Suppose we have two boxes and say box 1 and box 2. And say this has 2 white marbles and 3 red. And this has 4 white and 1 red. Okay, so 10 marbles in total. There's 6 white in total and 4 red in total. And say the probability I pick, box 1. Okay. So then let's say find the probability, select a box at random, half chance each, and a marble at random. Find probability, white marble selected. It seems because they're equal that it should get the total. I should get 3/5 for this. Let's compute it carefully and see if we get 3/5. So this is A. Yeah. Okay. So if we do this, probability of white, it might not be clear. This is equal to probability of white B1. I could write the union, but these are mutually exclusive. So I think you can jump right to the sum. Let white be a white marble picked. Probability, now I want to do this using the conditional probability. This is PB1, P white B1 plus PB2, P white B2. This is equal to a half. This is equal to 2/5 plus 4/5 and a half. Okay, so I get a half, 6/5, so I get 6/10. So I do get 3/5 as I thought I would. Okay. Now let's keep the marbles the same, but well, let's do something. Yeah, so let's change this. So let's make the boxes different. So suppose I have now. Yeah, so suppose I have, let's say I have 3 white and let's say I have 3 white here and 1 red. I don't know what I'm trying to do. Yeah, 3 white and 1 red, right. And over here I have 3 white, and how many red would I have left? 3 red, right? So I've kept it to 6 white and 4 red, and let's still make the same thing, B1, B2, B1. So probability of white now, still the same thing, P white B1 plus P white B2. I think you can see that it's a half and a half again. So I have a half. Probability of white is 3/4 plus a half. Probability of white this time is a half, right? So this gives me 1/4, 1/4 plus 3/8, or 2/8 plus 3/8, so I get 5/8. So it changed, right? It changed. Up here I have, this is 0.6, and this is 0.625. So I couldn't really do it by just counting all the white balls and expecting there to be just take that fraction, even though the selection of either box was the same. The reason is I did not any longer have 5 balls in each. The probability of a white went way up here in box 1. Well, it was pretty high in box 2 over here too, but it did change. It went up. Not sure how to explain. I guess I don't know. The intuition is I was losing me a little. It's too close, I think. But the fact is, I do get something that's not that's no longer just the fraction of the total. All right, that's all for this example. I'll do no more examples though coming. Just beware.